Okay, welcome to vertical circular motion. Now, unlike a regular circular motion or uniform circular motion that we've been dealing with, when you're dealing with vertical circular motion, the key thing that you wind up dealing with is you also have gravity. You have multiple forces coming together. And so what we're going to be doing here is a few things, because there's not one set formula for this, but you're going to need to create, first of all, a free body diagram. That's always going to be the first thing you're going to need to do. And you're going to use that to create an equation for the centripetal force. And that's when you solve for the unknown variable. Now, depending on your situation, each situation is going to be unique, and therefore you're going to need to go through this in order to find the things. So if we take a look, we're just trying to find an equation for each scenario here. Now, if you've got something spun on the top of a circle, you've got the tension keeping in a circle, and you've got gravity keeping in a circle. Now, both of these pointing towards the middle means that the centripetal force is going to be equal to the tension and the force of gravity combined together. Now, this is where you have a minimum velocity to keep the object in motion. Because the heavier the object, as you're spinning it around, eventually get to a point where near the top, you're not even going to have any tension acting on, because it's moving so slow that it's just going to fall. And so you need to have that velocity constantly kind of pushing it in that tangential direction outside, right, in order to keep this object moving in a circle. The next one, well, what if it's at the bottom? Well, at the bottom here, you've got the tension here, and you've got the force of gravity. Force of gravity, which is kind of holding it into place. And so in this case here, the centripetal force is going to be equal to the tension minus the force of gravity. Now, another way to put this, you could write it like this. You could say that the force centripetal is equal to the tension plus the force of gravity, where tension is positive and the force of gravity is negative. While technically correct, a lot of students wind up having some difficulty with that. This is the maximum velocity that you can have without breaking the string. This is where you're going to see the most tension happening within this object moving in a circle. Well, what happens if you've got a roller coaster at the bottom of a dip? Well, at the bottom of a dip, you've got this roller coaster car. The force of gravity is moving downwards, and there is a normal force pushing it up. And it's actually the normal force that's keeping it here. Because at the bottom, this is where you're going to see the maximum normal force. This is also known as apparent weight. Okay, 2 piece. That's where you see the maximum apparent weight. Now, in this case, the centripetal force is going to be equal to that normal force, again, minus that force of gravity. Where if it's at the top of a hill, right, you've got a force of gravity pushing it towards the middle. You've got the normal force keeping up to the top. And so the centripetal force is where you're going to see the force of gravity minus the normal force. You see how each one of these are different? Each one you're just looking at finding the formula based on your free body diagram. And this is where you're going to see the minimal normal force or apparent weight. Now with these questions, remember apparent weight is really just normal force. So if it's asking for what is the apparent weight, it's really asking for the normal force. And that centripetal force is always whatever's going towards the center of the circle. So let's take a look at a few other examples here. We've got a string. 45 centimeters long, moving at maximum speed. Where we see the maximum speed for that tension, that's again going to be at the bottom of the circle. So as this is moving down the circle, you've got your tension moving this way, force of gravity moving this way. So the centripetal force is equal to the tension minus the force of gravity. Or put another way, the centripetal force plus the force of gravity is equal to the tension. Now, the centripetal force is mv squared over r. Force of gravity is mg, is going to get that tension. I just realized I'm looking for the velocity. So really what we should be having is taking that. Let's just erase this here. Because we're looking for that, we will want to say mv squared over r is equal to that tension minus mg, that 9.81. So this is a 2 kilogram object, v squared over the radius of 0.45 meters is equal to 98 minus 2 times 9.81. Solving for this entire side here, that means that we've got, wrong pen, change the pen, 2v squared over 0.45 is equal to 17 point, that's equal to 78.38. When you multiply by 0.45 and divide by 2, you wind up with that v squared being 17.6. And square rooting that, you find that it's 4.2 meters per second. Taking a look at the next one. If the string is 55 centimeters long, we want to find, in this case, the minimum spinning speed. Okay, the minimum speed that we're spinning this 3 kilogram object in. So that again happens when force of gravity, except one of the things we should note here is that the tension is equal to 0. So the centripetal force is everything going towards the middle of the circle. That is going to be the force of gravity plus tension, but that tension in the rope is 0. So mv squared over r is equal to mg, and at this point you probably can even realize that I can divide both sides by mass and it cancels out because it is in every single one of the terms. And so we can divide it out. We're still looking for v squared, but we're going to multiply by radius. And so v is equal to the square root of gr, which means square root of 9.81 multiplied by 0.55. That is the given radius of the string. So this 2.3 meters per second is the speed at least that this needs to be spinning in order for this to stay in a circle. Anything less, this thing won't stay in a circle, it will fall. Okay, one more example here. This one is an apparent weight question. We've got the car on top, force of gravity, normal force. And so in this case, the centripetal force is equal to the force of gravity minus the normal force. Now, because we're looking for that apparent weight, we want to know what is the apparent weight of this person. We're looking for the normal force. So first thing, we're going to just add that to both sides. And then subtract the centripetal force. So the normal force is equal to mg minus mv squared over r. We can plug in our numbers at this point. It's 50 kilograms multiplied by 9.81 minus 50 kilograms. V squared, 7.85 meters per second squared, divided by that radius of 9.65 meters per second. Do your multiplication and exponents before the subtraction, which means it's 490.5 minus 319.2, or you wind up with an apparent weight of 171.3 newtons. Now, this is going to feel much lighter than normal, right? This person had an actual weight of 490.5 newtons, but they feel or have an apparent weight of only 171.3 newtons. That's it. If you got any questions, let me know. Thanks for watching.